So there's lots of strings in this project. For example, you have to save it to a file where the name of the file changes depending on the material. Maybe when you add a title or a legend to your plots, it depends on, you want to title it appropriately. So I'm just going to illustrate how we can use something called sprintf, which works just like fprintf, but instead of printing the command window, it creates a string and puts it into a variable. One other thing I want to mention is how we can store strings of different sizes. So here I have single quote strings, and here I have double quote strings. Remember, single quote strings are treated as arrays. So if I say geom circular rectangular I-beam, it's just going to put this array next to this array next to this array. So it's just one big string all grouped together, and that's fine if that's what we want to do. If we want to treat each of them separately, we can use single quote strings, or use double quote strings, where now they're each individual pieces. And this comes into play if we want to use sprintf and store all of our strings in one array. So now this array works a little bit better from what we might want it to be. So let's say I have this figure. It was generated, this is the data for a white pine with a I-beam and red maple, I-beam, and vertical orientation. So let's say I want to go ahead and add a title. So let's say my title, I want it to be, so I'm not going to create my title right away. I'm going to use sprintf. I'm going to define how I want my title. So sprintf, I want it to be type of material. So I'll insert the type of the material, insert the geometry, or I guess in the material, I'll say material. Geometry and orientation. Now I can go ahead and insert what variables store that data. So the material, let's say it's in some array, but it's red maple. For my geometry, I have this nice convenient array up here that states all my geometry. So I can say geom 3. So geometry now treats each of these separately. Remember, they're each separately. So if I say geom 3, it's just going to be I-beam. It's going to insert I-beam. And then I can do my orientation. Orientation was vertical. But once again, if that's in its own variable, then I can go ahead and call that vertical orientation within an array. Now I can go say title T. So here, now my title is dynamic. It changes based on what my materials are, my geometry, and my orientation. So I can add in that information. Same thing with a legend. You can use sprintf to identify your different things that you want to insert. I don't have to do this separately. I could do this right in here as well. Same thing works. So I can make my titles, my legends, any text dynamic. Same thing with file names. So let's say I want my file name to be dependent on what my material is. So sprintf s geometry.mat. So now I can say red maple and geom 3. So I can go ahead and do my file name and now save to my file name. In order to do this one though, you have to do that. Now I can list out my variables, etc. You need parentheses to say save to whatever this file name is. This file name is now a separate string, and then what variables. Okay, so sprintf might be really useful. Double quote strings might be really useful. If we use double quote strings and they're scalars, we can put them in an array, index it like we do with normal numbers. sprintf works just the same as fprintf, except rather than printing it out to the command window, it now just prints it out to store it into another variable that we can use later on. So this might be useful. It might help you shorten up your code, less branching statements, and give you some chance to do dynamic naming of things if you're interested, for titles, but also when you're required for things like file names.